Hi, welcome back to the Shikong Math Lab differential equation problem solving section. So today we're solving a very interesting problem. Here's the problem we are going to solve. It's x squared minus sine squared y dx plus x sine 2y dy equal to 0 with the initial condition y1 equal to pi over 3. So for this problem, this is the first order nonlinear one. So as always, I will try to see the exact differential equations will work or not. Okay, so this is the problem we try to solve here, right? Like I always do before. First things here I like to do is just moving the dx under. So here I will have x squared minus sine squared y plus x sine 2y dy dx equal to 0. So in here, we have y and 2y. So probably later we're going to use the double angle formula. And so that just, make it handy so you can check the double angles. All right, so here in order to use, so let's try to say, so this one here, this is be my mxy, okay, and this one be my nxy here. Okay, so this is mxy. So this is nxy. Okay, so now the first things we do is to check, right? So I'm taking the partial derivative of mxy. That means I'm taking the derivative with respect to y. So what is here? So this will be negative 2 sine y. Then the chain rule sine y is cosine y. Okay, now for the nxy, I need to take the partial derivative to the x here. So the partial derivative to the x, the yellow one will just be the sine 2y. And I know the sine 2y, the double angle formula can be the 2 sine y cosine y. Wow, looks quite similar, my and nx. Okay, partial derivative, but they are not equal because there is differences in the, in the signs here. Okay, so then that's why, because the first, okay, so this is step number 1. So I know the my is unfortunately not equal to the nx. So my second step here, I need to find the integrations factor. So here is du dx. I use the my, right? So this is equal to the my minus nx over the nxy times u. Hopefully, this one will turns out to be a very good form. So let's take a look. My is negative 2 sine y cosine y minus 2 sine y cosine y. Then the nx is x sine 2y here, right? So here this is x sine 2y. And then times u. Not bad. So this the top, if you combine, so it will be negative 4 sine. Okay, so or I like to do this maybe. So okay, so the top here will be negative 2 sine 2y. Then I have x sine 2y. Wow, that turns out times u. Then that turns out pretty good. Sine 2y, sine 2y. So negative 2x equal to times u. Okay, so now in order to find u, let's do a variable separations here. So here, so put the u, move u under, so du over u is equal to negative 2x dx. Okay, Now I can integrate both sides. So when you integrate both sides, so this will be ln u, then this will be negative 2 ln x, then this will be ln 1 over x squares, right? So I can come out with u is equal to what? U equal to 1 over x squared. Oh, that's pretty good. Okay, so let me highlight this one. Okay, so let me highlight this one. U equal to 1 over x squared. Then what I need to do here, I need to times back to my original function, right? Okay, so now I'm times back to my original function. So you need to times all the way back here. Okay, all right, so here, okay, so let's be careful not making any silly algebra mistake. So this is 1 over x squared minus sine square y, okay, then plus 1 over x squared times x sine 2y, right, dy dx equal to 0. Okay, let's simplify it a little bit. So x squared, so this will be 1 minus sine square y, so this is x squared. Okay, then plus x and x squared, so it's 1 over x sine 2y dy dx equal to 0. So this is become homogeneous again. So now let me highlight in the color again. Okay, so this one will be my new mxy, and this one will be my new nxy's here. Okay, so let's try to write it so we don't make any silly mistake. So this is mxy equal to 1 minus sine square y x squared. Now for this ones here, this is nxy is equal to sine 2y and the x. Okay, now let's take the partial derivative for y here. So the partial derivative for y will be, you take the negative 2. Okay, so it will be the negative 2. Okay, so this one's here, negative 2 sine square cosine square y, right? So this is a sine y, then chain rule be a cosine y, correct? And then the bottom still is x squared. Okay, so now for this ones here, I need to do the partial derivative respect to x. So I need to, so this one I can rewrite as the x to the negative 1 power sine 2y here, right? So this will be negative x minus negative 1 minus 1, negative 2, so it's x squared. Then the sine 2y still stayed the same. So this will be x squared, so negative 2 sine y cosine y. Yes, what happens here? They are equal. Beautiful. Okay, that's what we are looking for. We hope they are they equals here. Okay, if they are equals, right? So then the next step, how to solve in the homogeneous exact. Okay, so the next step, I'm going to have a function, phi functions here. The partial of xy will be equal to my mxy, so it's 1 minus sine square y x squared, okay? And I'm going to have the psi y xy will be equal to what? Sine 2y of the x's, right? Okay, so now with this I need to integrate respect to x and integrate the sine x, xy dx become, right? So that means I'm integrating. Okay, so that means I'm integrating 1 minus x squared sine square y dx. So I will have x. So this is the negative 2. So it becomes positive x. Okay, sine square y. Because I'm integrating x, so I'm going to have a constant term, is hy term here. Okay, so this one's here. Then for I go to the here, continue with the here. These functions here, then I take the partial derivative to y of xy. So the partial derivative to y, so this is the 0, then y will be x2 sine y cosine y plus h prime y. Okay, so because this both is right, so this one here is psi y, this one is right. So we set what? We set both of them equal, right? So after I set both of them equal, so I will see here h prime y. Okay, if you want here, you can. So this is sine 2y. Right, plus h prime y. So the sine 2y, okay, so just be very careful about the algebra, you will get it, right? So this is sine 2y over x equal to sine 2y over x plus h prime y. So I know h prime y is equal to what? Equal to 0, right? So that means my hy going to be some constants. So now I'm going back to this equation here. All right. So let me highlight here. This is my 5 functions here. So now I know my answers here are going to be, is my process number 5, 6. All right. So step number 6. So I know the 5xy equal to some constant, right? So that means x plus sine square y to the x equal to some constants here. Okay, now let's see what is my initial condition. My initial condition is y1 equal to the pi over 3. Okay, so the y1 equal to, okay, so I need to solve for c, right? So y1 equal to the pi over 3. Okay, pi over 3. Okay, so now x is 1 plus 1 sine pi over 3. The sine 60 degree is the square root of the 3 over 2. So you square that, it will be 3 over 4 equal to c. So c is equal to the 7 over 4. Okay, so my final answer will be x plus x sine square y equal to the 7 over 4. That's it. Okay, so that is the solution for this differential equation. Well, it's not too bad. It's just very tedious, and we just need to be very careful. Don't make any like the silly algebra mistake, and finally get the solution. All right, I hope this helped you to solve this problem, and have a good day. We will talk some other problem the next time. All right. Enjoy your day. Okay, bye bye. Talk to you later. Okay, bye bye.